Okay, so hello everyone, welcome. Can you hear me?
Yes.
Yes, sir.
Okay. Okay, just we are waiting 1 minute or 2 minutes for joining all of those other participants. Then we'll start.
Can I ask a question? Or
Please. Yeah, please.
I was wondering if a code is pre-written and I need to change the study area. So how should I do that? I mean, I can share a link, and I would like to know how I can use that code for my area of interest and export whatever. But
Okay.
I need to extract my area for that pre-written code. May I share the link here?
Yeah, no problem. You can share this link.
Okay, thanks. I'll be sharing.
Okay, so let me check.
And I'm also sharing the asset link. I'm in my area of interest.
Okay. Okay, so kindly share your asset or area of interest.
Yes, I have shared. Is that available, the link?
Okay, got it. Yeah. Also share my screen.
Okay.
Okay, so now can you see my screen?
Yes.
Okay. Okay, so in this time, this is the code, and this code you want to just add your study area. Okay, so this
Yes.
is your study area boundary shape file. Okay. Uh, So then simply import that study area first of all in this here. Then simply copy. You can see simply copy that from here.
Yes.
Simply copy this line of the code and then paste in here. So basically in this time they are used a lot of data set and then predict the land surface temperature. So in this time here you just need to change. So in this time it show the result only for the geometry. Okay, so in this time you want to show the result for your own study area. So for that just simply paste your code and simply remove the previous one and then simply put here the variable as a geometry. So basically, previous variable is geometry, so you have to use the same variable name.
Okay.
So now just try to check the code. Okay, so now we can get the result for your study area of this Khulna city, which is study only using here. Okay, so now if we can get the actual and predicted land use, LST for that your study area, which we imported in here. Okay.
Okay, but what about the visualization? Actually, like the map, the result is showing results for all other area, but I would like to show
Okay.
only that area of interest,
Okay.
and
Okay.
other area will be excluded from
Okay.
the visualization or
Okay.
something.
For that, you can simply use here that clip function, and then it's just simply clip with your study area. Okay, so for that you can see here, so mainly in this time this code used here that precipitation data, rainfall data, as well as also population data. Okay,
Yeah,
so
so
in
I
this
have to
time,
click for
yeah,
each category of code, or a general clip function is
yeah,
enough.
general clip function is enough. Okay, so in this time, after applying the reducer all time you put the use the clip function for your specific boundary. Okay, and without reducer is not clip. Okay, so if suppose you can simply use here the clip function without reducer, then it will be not work. It's showing the result clip is not a function. Okay, so
Yes, yes,
before
yes.
clipping must use the reduce and then use the clip function, then it will be work,
Okay.
and then visualize. Okay, so you also try to that. I hope it will be work. There is no problem. Just in this time, suppose in the rain they use here the for whole world, so in this time you can simply just use here the clip function. Then also LST, just use here the clip function.
Uh,
Population, just use here the clip function.
it
Okay.
would be nice if you could please demonstrate me the clip function using here.
Okay, okay, just
That would be nice.
suppose just I simply use here that, and before that, okay. And another thing is that when you want to use here the clip function, then sometime the chart is not work. Okay, so basically chart is work for that image collection. Okay, suppose image collection, it has a lot of images, suppose 10 images. But when you want to use here the, suppose in this time I use here the reducer, suppose I calculate the total precipitation, so then it will be convert into a one single image of total precipitation.
Okay, okay.
Okay, one total image. So in this time, what can I do for that? Just I show you that. Suppose, okay, so it combine all of those. You can see rain, LST, population elevation, and update marks with the population. Then use there the sample data about that. So from here we are just, okay, also use there the trend. Okay, so predict, okay, classify with the regression model and prediction LST. Okay, so in this time, in the final layer, we just simply use the clip function and then check. Okay, final layer, just clip with the boundary. Is that a geometry? Simply copy that and then try to, yeah, simply paste in here. Okay, so now let's check the result. I think now it show the final result, mainly prediction LST, show only for your boundary. It just not need. Okay, so in this time we can get the one layer. So in this time, just I simply center focus of your boundary shape file. So for that, we are just use here the map dot center object and put here the geometry. Okay, and then click to the, okay, geometry. Put here the zoom level, suppose 5. And it's not need. Let's state the, we also zoom. Okay, it's a very small region, so that's why. Yeah. So now this is your predicted, like predict LST prediction LST about that tip format. Okay. So now further you can easily export and then make the map for the prediction LST. Okay. Just clip with your final layer. Okay.
So I have to use the clip function for each of the layer. I mean,
Okay. Okay.
segment. or I can use a general clip function that will be applied for all other layers.
Yes. So in this time, our final output is the LST prediction. So mainly all of those data we use and then create the final LST for the whole world. So in this time, just you can simply use the clip and then get the result for the final prediction result for this study area.
Okay. If I want to use for another layer, then how should I write or use the clip function, say for elevation either or population
Okay.
in this
Okay.
case?
Okay. So for that, here you can see the elevation. So this is the elevation. So now you want to need the elevation only for your study area. Okay. So first of all, simply find out your elevation in this time. This image is already, suppose this elevation image is already stored in a variable. So I need to find out the variable name. So just try to find out the variable name elevation. So layer name is the elevation. Just I find out the map.add layer function. You can see, yeah. So you can see this is the elevation. Okay, and it is a false because in this time it not show the result. So in this time you can simply use at the clip function, clip with geometry. So now click to the run. In this time we can get the result of elevation only for your boundary. Okay, now let's check is the LST for that, and it's just prediction and elevation. So we can get the result for elevation in this time in here.
Okay. Okay. So each time I have to use the clip function with the add layer section, right?
Yes, yes,
For
yes,
each of my data set.
yes.
Okay. Okay. Thank you. Thank you so much.
Okay. Okay.
Sorry, sir.
Yeah, please. So okay, any question, please? Yeah.
I've, I've also shared my code
Yeah, just a minute. I simply share the previous code. Then show you your code.
this code.
Okay, so now, okay, so this is your code, yeah?
Yes, with the address.
Okay, so let me check about that. So mainly this type of problem when you face, when you want to work with for the big region, okay, then we have to need to increase the scale value or also use the max pixel value. Then this type of problem we can easily overcome and then easily get the result for that. So let me check. Okay, so what is the problem you face for that? Okay, okay, it's showing the result for that. Too many pixel in region. Okay, so and you want
Yes.
to too many pixel and you want to try to make the chart. Yeah, did you make the chart for that?
Yes.
Okay.
No, I did not manage because I was told there was so many pixels.
Okay. Dictionary. Yeah. So what do you want to use this dictionary? What is your main target for use the dictionary? For calculating the
No,
area?
actually, I was following up with. Yes.
Okay, calculating the area.
Yes.
Okay, so in this time, you just try to calculate the area. So in this time here, you can see we can get the dictionary error. In this time, there are a lot of pixel value is available as a big region. Okay, so further it's showing that is not work. So in this time here, you can see the reduce region function has another argument. This argument name is that max pixel argument. Okay, so in this time we have to add here the another argument when you face this type of problem. Just add here the, you can see it also already showing about the max pixel. So simply copy from here and then paste and then put here the highest value 1 is 13. Okay, 1 into 10 to the power 13. Okay, so now let's check. Yeah, so now let's check. You can check for the problem face now. We can get the first dictionary, what's the problem, then move to the second. I think now it will be work about that, you can see. we can get the result NAWI and then convert that the another unit. Okay, so do for the same things for this. In this time we can see it also showing about the error in map, error generating chart. Okay, so in this time we can see we can get the problem for
Okay.
creating the chart about that. So just I simply show, yeah, we make the collection and UI chart image the series. Okay. So in this time, when you face this type of problem, I think I already discussed about that how we can easily create the CSV file format. Okay, so this is another way for creating the CSV file and download the time series data as a Excel file. Or another way is that you also increase the value. Okay, for the big region, just increase the value. Okay, suppose in this time I put here the 100-meter scale pixel area, 100-meter, increase that. So now let's check about that, because it's a big region, and when I want to put here the 10-meter pixel area, then there's a lot of region. Okay, so that's why we can get the sum it loaded, it exists, the limit, memory limit exists, we can get. So in this time I just simply calculate the chart, get the 100-meter pixel area. Okay, so now now it will work. Yeah.
Okay. Please, you share me the
Okay,
script
okay.
in the console, please.
Okay. Okay, so anyone any problem
Thank you, sir.
or previous class or any doubt? Okay, so if you there is a no problem, then we just try to start our today's session. So basically today I will try to discuss about that machine learning algorithm, how we can easily use the different types of machine learning algorithm for the making the land use land cover classification map, and how we can easily check the accuracy, then calculate the area. So today I will try to cover the lot of things for that land use land cover classification. Okay, so let's go. Okay, so first of all, we have to know about the machine learning in Art Engine platform. Okay, so basically, machine learning we can easily use in Art Engine platform for the different types of purpose. Suppose prediction, as well as we can also use for that land use land cover for classification or regression. So there's a lot of way we are using the machine learning in Google Earth Engine platform, and in Google Earth Engine platform, we can get the three types of machine learning algorithm. Okay, suppose one is the supervised classification, unsupervised classification, and regression. Okay, so in this time, first of all, supervised class, I will show you that supervised and unsupervised. Okay, so regression model is our another advanced topic for that, for regression or predict, such as LST. So previous for I also show you about the regression, but regression is our another advanced topic, how we can easily use the regression and the predict for the different types of water quality, then forest cover, then profiled. So this type of things we try to cover the another advanced online training program. But in this online training program, I will show you the supervised classification and unsupervised classification. Okay, so what is the supervised, what is the unsupervised, and how we can easily use the supervised and unsupervised classification. So mainly in machine learning technique for the classifying land is to use the ground truth example to take it is the model of different classes. So mainly when you want to work with the supervised classification, so first of all, you need to take the training sample from your ground. Okay, so in this time, how we can easily take the training sample, I will show you all of this process. Mainly we are using the different types of spectral signature or different types of band combination to take the training sample from the Google Earth Engine platform. So mainly supervised classification, when you want to do, you must take the training point or training sample. Okay, and when you want to do for the unsupervised classification, you don't need to take any types of training sample, or you don't need to take any types of ground truth data. Okay, so supervised, mainly you need to take the training sample, and unsupervised, you don't need to take any types of training sample or training data, don't need. Okay, so in this time, first of all, you can see what is the classifier. So classifier, mainly we can get the algorithm which implement the classification on dataset is known as classifier. So in this time, suppose I have a dataset, any dataset, or it can be numerical or non-numerical, any dataset I have. So now this dataset I want to implement so a algorithm. Okay, so this algorithm called as a classifier. So mainly we can get the two types of classification main. One is the binary classifier, another is the multi-class classifier. So binary classifier have only two value. Okay, suppose yes or no, suppose male or female, spam or not spam, cat or dog, forest, deforestation. Okay, so in binary classifier we have just only use the two outcome. Okay, and when you want to work for the multi-class classifier, so more than two outcome, in the multi-class classifier we can get the more than two outcome, such as classification of crop types. Suppose you want to classify the crop types. Okay, classification of music, classification of land use, land cover classification. Okay, so when you take the result for the outcome, when you get the outcome more than two, it's a multi-class classifier. And when we can get the result for only for the two classification outcome, it's the binary classifier. And binary classifier, suppose you want to classify it only for the forest and deforestation, so it's only for the two outcome result, if forest or not deforestation. Okay, so forest and deforestation, spam or not spam, cat or dog, yes or no. And multi-class classifier, when you want to suppose more than two outcome, suppose I want to make the land use land cover classification map for, I want to classify the build up area, then vegetation, water body, barren land, so it is a multi-class classifier. And we have to use different classifier for the binary classifier and multi-class classifier. We have to use here the different classifier. Suppose binary classifier, we are using here the support vector machine. So support vector machine work very well for the binary classifier. Multi-class classifier work very well for the random forest classifier, or also cart classifier, mainly classification and regression trees classifier. So this type of classifier work for the both of other classifier. So mainly when you want to select your classifier, first of all, you have to identify your outcome. What you get, your outcome is only for the two class or more than two class. Okay, then choose your classifier. Suppose you want to classify it only for the forest and deforestation. So in this time it's a binary classifier. So for that you have to choose the binary classifier, such as support vector machine. Suppose you want to make the multi-class classifier. Suppose you want to classify the build-up area, vegetation, barren land, water body. So it's a multi-class. So then you have to choose the multi-class classifier as the random forest classifier or classification regression trees classifier. Okay. So it's different on your outcome, possible outcome. What is your possible outcome? Then you want to easily identify which classifier you need to use in here. This time I show you that how we can easily use the machine learning in Google Earth Engine platform for creating the land use and land cover classification, and then how we can easily check the accuracy assessment of the land use land cover classification, then how to calculate the area. Okay, and then how to add the legend on your land use land cover classification map. So all of this we try to complete it. So first of all, we have to know about the process to make the land use land cover classification map in Google Earth Engine platform. Suppose when you want to work with the ArcMap software or QGIS software, they have the another flowchart or another method. So in this time we are using the Google Earth Engine platform. So mainly Google Earth Engine platform is a totally cloud-based platform. So that's why in this time we don't need to download any types of satellite images. Okay. So we can easily access all of those satellite images from the Google Earth Engine data catalog and use it. So first of all, first step, you need to selecting your ROI, region of interest. Suppose you want to make the land use land cover classification map for Dhaka city. You can simply select your study area as a Dhaka city or any specific boundary. So first of all, you have to selecting your region of interest, and then choose and filtering the image collection. In this time, if you want, you can use here the Lancet, or if you want, you can use here the Sentinel. No problem. Okay, just choose and then filter the image collection. And how we can filter the image collection, I already covered for the Sentinel and Lancet. Already done it for the filtering the image collection. After filtering the image collection, we have to collect the training point. So it's very important for collecting the training point. There are a lot of way for collecting the training point. If you want, you can simply go to the field and take the ground truth training point as a CSV file. Or suppose you can take the lat long and then simply take the feature about from the ground. Okay, or if you want, you can also use at the different types of band combination. Okay, so we can use at the different types of band combination, and we can easily identify the different types of feature from the satellite images, and then we can take the training point. Okay, so how we can easily take the training point, all of those things I will share after a few minutes, so then you can easily understand about that. And then after collecting the training point, we have to merge. Okay, so all of this training point we have to merge into a single variable. Okay, after merge the training point, we have to create a data set. So in this time, this data set mainly combination of all of those band pixel value. Okay, which band you want to use, this type of band pixel value, create a data set. Okay, suppose I use at the red, green, blue, near infrared, short of infrared, and also other band I can easily use. And this type of band, I just extract the pixel value from all of those training point. Okay, so after merging all of those training point, I need to extract the band pixel value. Okay, so for that, first of all, I need to select all of those band, which band I want to use to make extract the pixel value. Okay, and then after creating this data set we need to divide into two ways. So suppose I use here the 80% data for train my model, and suppose 20% data for test my model. Okay, so in this time, in the machine learning, so mainly machine learning, when you want to work in the machine learning, we have to use the some data for train our model, and we have also need to use the some data for test our model. So it is the basic concept of the machine learning. When you want to use the any types of machine learning, not only for the Google Earth Engine, suppose you want to use the machine learning for the other platform also. For that, you first of all you take the some data set for train your model, and some data set you just take for train test your model. Okay, train set and test set. Okay, so mainly some people they are the different ratio we can use. Suppose 70% data for train and 30% data for test, or 20% data for train or 80% data for test. So mainly train is larger than test. Okay, then we divide that, and after use the train data set, and then we just create the classifier. Okay, after divide the data set, we have to need the classifier. In this time, if you want, you can use here the random forest, or if you want, you can use here the support vector machine or any classifier. We have to apply in this time in here. Okay, and then train our model. Okay, then we train our model using the 80% data or 70% data, then create the classified the image and display the image. Finally simply display, and then we have to check the accuracy assessment of this map. So for that, we have to create the confusion matrix, and using this confusion matrix we can easily calculate the overall accuracy, then also calculate the kappa accuracy, producer accuracy, consumer accuracy. So this type of accuracy we can easily calculate from the confusion matrix. And then we also need to calculate the area for each classes. Suppose how much build-up area, how much vegetation, how much water body. So this type of area we can easily calculate in Google Earth Engine platform. So this is the basic process or basic step for making the land use land cover classification map. So anyone, any question, please? Okay, we can also use here the SAR data for the classification. It's another algorithm for that. Okay, same process, just use here the band for the SAR, which band you want to use for that. Okay, polarization. Okay, this type of things we need to work for that. Okay, so in this time, I show you the practically all of those things one by one. So just open a new code editor. So first of all, you have to import your boundary. Yes, I also show you the dynamic change also. Okay, so for that we have to cover this part. Okay, so step by step I will try to show you all of those things. Don't worry for that. Okay, so same process, but we are also created the annual image collection. Okay, when you want to make the land use land cover classification for multi-year, then we have to create the multi-year image collection, annual image collection. Okay, so this part is not completed yet, so I will show you that how we can easily create the multi-year image collection, and then how we can easily use it for land use land cover classification map for the further class. Okay, so basically it also need about that when you want to make the change detection, we have to need the multi-year land use land cover classification. Okay, so let's go. So first of all, I just simply imported our boundary. Okay, suppose in this time Dhaka city is my boundary, I simply import that. It will be imported and default name as a table. I just simply change it. I put the name suppose RY. Okay. So my first step is done. It's my first step selecting your ROI or region of interest. Okay. So in this time I have to choose and filter my image collection. So for that, I simply go to my browse data catalog. Suppose in this time I want to use at the suppose land city image collection I want to use. Okay, and I want to make the land use land cover map. Suppose for year of 2020 or 22. Okay, so I simply click on the land set, and you can also apply the same process for Sentinel-2 satellite imagery also. Okay, so here you can see here. So I want to use the Landsat 8 image collection. And mainly we are using the surface reflectance satellite image for making the land use land cover classification map. Okay. So just click on the surface reflectance. And here I can get this time period, you can see. So in this time, this image collection, just I need to filter. Okay. And I already covered this part, how we can easily filter for the previous classes. In this time, I just write the code.
Alhamdulillah.
Time if you want, you can use that the single image, single time period image, or if you want, you can also use that the median composite. I want to use the median composite. Both of image, same process. And now I want to display the result. Click with my study area RY. So now display the image. Okay, and also focus the center of this boundary shape file. Use here the map.center object function. Suppose 10 and clear one. So now it's load a image year of 2020 median image collection for Dhaka city. Okay, we also use here the another argument for that filtering the cloud cover also. Okay, so use here the filter metadata and put here the suppose cloud cover image properties less than 1. So now click the ground. So in this time I just show the display the result. So in this time it show the default visualization. So I set the visualization from here. So just you can see I want to add here the suppose red band, green band, and blue band. Also stress 98% for better looking of the satellite image. Apply it. So now here you can see I can get this very good satellite images for year of 2020 median composite. So now this is my image, and in this image I just need to apply the machine learning for creating the land use and land cover classification map. And in this time, I want to use here the supervised machine learning method. So when you want to work with the supervised machine learning method, you must take the training sample. So in this time, I show you that how we can easily create the training sample. Okay. So in this time, you try to, so how training sample you collect for each class. So mainly depends on your study area. Suppose you want to work for the big study area, then you try to take the more training point. Actually, when you want to use the more training point, then you can get the more better accuracy. Okay. So at least minimum 50 number of class, 50 number of training sample for each classes. You take the training sample. So in this time, here you can see I take the training sample. Okay. So for that, I simply click on here. You can see a new geometry will be added in here. Okay. And then also you can see the property, layer properties. Click on the layer properties. So here I can get, first of all, I take the training point, suppose water pixel value I want to extract from here. So for that, just take a water. You can put any name as a variable. Okay. Then geometry feature collection. In this time, I just not take the one sample of water. I take the more sample. So for that, use the collection, feature collection, and property. In this time, you can use any property name. Okay. And property will be same for all of classes. Okay. Suppose I put the property for class for water. But when I also take the training point for the other class, I use the same property name class. Okay. So property name will be same all time. In this time, I just simply set the value for all of those training sample of water value will be 0. I put the 0. Okay. And then okay. So I start from the 0, then 1, then 2, then 3, then 4, like that. So click on okay. So now I can see it also change about that water. Okay. So in this time, I already live in Dhaka city, so that's why I very know well about that. This is the water body, this is the lake about that. Also, this is the water body. But when you want to make the land use land cover classification map for unknown place, okay, suppose which place you don't visit physically, you want to make the land use land cover classification map. So for that, we have to use some band combination technique and identify for different types of feature. Okay, so in this time I will show you some band combination technique to identify for the different types of feature from the satellite images. Suppose, and using this technique, you can easily make for any region in the world for making the land use land cover classification map and take the training sample. Okay, so it's very important for that, make the land use land cover classification map. You have to use the different types of band combination for identify for the different types of feature on the ground. So first of all, this called the natural color. So red, green, and blue. So mainly when you use the red, green, and blue, we can get the natural color or true color. Mainly what human eye can see. Naturally I can get this type of feature. So it's a natural color. So if you want, you can also use here the other band combination, such as I also show you that. Suppose near infrared, then red, then green. So in this time here you can see we get the result for another satellite image. In this time I can get the look like that. Okay, all time for Landsat or also Sentinel. When you apply the band combination near infrared, red and green, near infrared, red and green, Landsat and Sentinel, both of image. When you apply the near infrared, red and green, we can get the water body as a black or dark color all time for any for the whole world or any region. Okay, so near infrared, red and green. When you apply the near infrared, red and green, we get the result of water body as a black or dark color. Yes, you can get the black color. Okay, you can get the result as a black color. Okay, and not only for that, when you use this band combination near infrared, red and green, we can get the vegetation as a red color. Okay, so you can see this type of red color identify about the vegetation. Okay, And this type of black color or dark color identify about that water body. Okay, so this is the one kind of band combination. So it's very useful for identify the water body and also vegetation. Suppose better red, we can easily identify the more vegetation, and black or dark we can get the result for water body. So in this time I can easily identify this is the water body, also this is the water body, also you can see the black, you can see this is the water body, also you can get the water body. Okay, water body, you can get the lot of water, but you can easily visualize in my satellite image. So now I can simply take the training sample from here. This time I can take the only for the 22. But when you want to make the land use land crop classification for your region, then take the training point more than 50 for better accuracy. Okay. So in this time, this is the one kind of band combination, near infrared, red, and green. Okay. So mainly when you use that, we can get the water body as a black, vegetation you can get the red. Okay. So in this time, I also show you the another band combination. Suppose this band combination called the short wave infrared one, and near infrared and red. Okay. So it also popular band combination, and we are easily identify the vegetation, cropland, agricultural land, barren land using this band combination. Okay, for any satellite image, Landsat or Sentinel, shortwave infrared, near infrared, and red. Apply. Okay. So now here you can see we can get this type of result. So in this time, here you can see we can get the two types of vegetation color. We can get this type of green color. Also, you can get this type of green color. Okay. Here you can see this type of green color and also this type of light green color. And also we can get this type of green color. Okay. Also, you can see we can easily identify it's a barren land. Okay. So it's a barren land. We can get this type of gray color. And this type of, you can see it's also wetland. It's one kind of barren land also. Okay. But this type of color you can see it's also called about the wetland. Also you can see this is the wetland. Okay, and it's a barren land or fallow land about that. Yeah, you can get that. Also it's a wetland. If you want, you can also classify the suppose barren land, also suppose wetland. Then you can easily take the class and take the training point for the wetland, and also take the training point for the barren land. Also you can see we can get this type of result. So this type of green pixel value, basically in this time it identify about that cropland or agricultural land, and this type of green color pixel value identify about that for that vegetation. It can be not cropland, but it's a vegetation such as trees or tree cover about that. Okay. So in this time, suppose in this time I just take the training point for the vegetation, and I not classified for the agricultural and vegetation. I just all of those agricultural and other types of vegetation or trees considered as a vegetation. Okay. Or if you want, you can also separate. Okay. For separate, just take the training sample for your specific class. But in this time, I just including the two classes, vegetation and cropland or agricultural land, make a one class. Okay. So just click on here, new geometry, and then simply click on here and put the suppose vegetation. And then same feature collection, property, set the property name such as class. Property name will be same all time, and set the value for 0, 1. Okay, it will be 1. Then okay. So now I just take the training sample for the vegetation and I consider all of those vegetation. Okay. If you want, you can also classify it in here also. Suppose cropland and also vegetation, differentiate. But in this time, I just take the training sample for one class. Vegetation and agriculture, I make the one class as a vegetation. Okay, as well as I also take the training point for suppose barren land. And then feature collection, property such as a class 0, 1, 2. Okay. 0, then 1, then 2 in barren land. So in this time, I just considered the barren land and wetland as a fallow land or barren land. Okay, so if you want, you can also differentiate it. But this time I take the same. Suppose barren land, all of those things I just combine. Okay, just take this barren land. Okay. And suppose finally I also take the training point for suppose okay, build up or settlement. So same feature collection, property, set the property for class and 0, 1 to 3. Okay. Property will be same, just we change the value. So now I just take the training point for the build up. Okay. So for the build up, we are also using this type of pen combination. Suppose I use the natural color, suppose red, green, and blue. And not only for that, lot of band combination. You also try to find out the sort of the Google or other site. You can get a lot of band combination. We are used for the different types of feature. We can easily identify, such as mineral, also different types of gold detection or mineral identification, rock. Okay, so that's why we have to use the different types of band combination for identify for the different types of mineral, different types of rock or gold detection about that. Okay, so it's also possible to use the different types of band combination. Okay, so now it's loaded. Yeah. So now I apply. So now we can get the result for, yeah, true color composite. Okay, so in this time I take the training point for the build up. So you can see this is the build up region. Or also you can use here the different types of index, such as for NDVI, use here the normalized difference vegetation index. Okay, so I already covered this part, how we can easily calculate the different types of index. Okay, if you want, you can also add here the suppose normalized difference build up index. You can also use in here. So it has the another formula. Okay, just put the formula, then you can easily get the NDBI. Okay, normalized difference build up index formula you can also get from here, as well as you can also use here the barren land index or BI index to identify for the barren land also. I think some networking issue. Yeah. Okay. So I take this some training point for the build up. Okay, so in this time it's not fixed for the training sample. Okay, so after making this map, I need to check the accuracy. If I face any problem on the accuracy, then I also need to increasing training sample or decreasing the training sample. Okay, but it's not a fix. Okay, so first of all, we just simply take the training sample, and after when I can get the better land use land cover accuracy, then it will be fixed. But suppose I use this training point, I can get the low accuracy, then it's not correct. So then I also recheck my training sample, increasing or decreasing or removing. Okay, so first of all, I take this training point, look like that. So in this time, after taking the training point, we move to our third step. Okay, our third step is that we need to merge. Okay, all of the training point need to merge all of the training point. So in this time, we simply merge and store all of those training point in a one variable. So you can easily take any variable name. I put the variable name, suppose sample. Okay, In this variable, I store it all of those training sample. I need to merge. So I simply call the water merge with vegetation. It merged with Berlin. Then it's merged with build up. Build up. Okay. So water, vegetation, Berlin, and build up. So now you want to check how many training sample you take. So in this time, simply use at the print and then use at the sample. Click to the run. In this time, it show the result, how much training sample you take. In this time, here again, take total 122 training sample. Okay, 122 training sample. In this time, you can see we can get the image black image because we are not import the visualization in our code. So just I simply import the visualization. Suppose red, green, and blue. True color composite 98%. Apply and then import and simply copy the variable name and simply paste the variable name after the object name. Okay. Then put the layer name, suppose image. So now it's set it. Okay, now we can get the true color composite image. Okay, and how much training point we can take? We take the 122 training sample. In this time, I move to our fourth number of step. In this time, I need to create the data set. Okay, so mainly this data set is the combination of different bands pixel value. Okay, so in this time, I have to select the some band. So which band I want to use as the input in my model. Okay, so I need to select some band. So I simply take a variable, suppose bands. And in this variable, I just make a list all of those bands which I use in here. So basically here you can see we can get this type of band from this image collection. Okay, let me check. I simply open this image data catalog. Yeah, so here you can see the bands. So mainly in this time, here you can see total 7 band is available. SRB1, SRB2, SRB3, SRB4, SRB6, SRB7. Okay. So in this time I use all of those band. Okay. And extract the band pixel value, okay, as a spectral signature. So in this time I simply put here the SRB1, SRB2. Also take the band for SRB3. Also take the band for SRB4, SRB5, SRB6, and SRB7. Okay, so in this time I just take this type of band, SRB1, SRB2, SRB3. Just take all of those band. Not only for that, if you want, you can also add here some external band. Okay, suppose in this time I put here the NDVI. Put here, suppose NDVI. Suppose put here EVI. Okay. Also put here the suppose another band for BI, Badland Index. So mainly this type of band, NDVI, NDVI, EVI, BI, it's also neat when you want to work for that very, very difficult classification. Suppose you want to classify the crop. Okay, so then we have to use the more band. Okay, so that we can easily separate the different suppose we can, when you want to make the crop classification, suppose rice, jute, or sugar cane, this type of things, then we have to also need the more information for that their pixel value. Okay, so further we have to use this type of external band. Not only for that, many external band we have to use for the different types of classification as input. Okay, so it also possible to use the Google Earth Engine platform, also input the external band. Okay, and basically you can see this type of internal band is already available in our satellite image. Okay, But external band, NDVI, NDWI, this type of band is not available in here. So for that, we have to generate the external band such as NDVI, EVI, or SAVI, or any which band you want to need. Okay, simply create. Okay, then we also get the better accuracy of the land use land cover classification map. So I'll show you the later about that how you can easily add the band. So in this time I just show only for this band. In this time I just need to extract the band pixel value, all of those band pixel value from 122 training sample. Suppose here you can see the list about that all of those training sample. Suppose first training point, I need to extract all of those band pixel value. Okay, suppose SRB1, SRB2, SRB3, SRB4, SRB5, SRB6, SRB7. What's the band value for 0 number training point? What is the band value for all of those band value for 1 number training point? What is the band value for 2? And up to 122 training sample, I just need to extract the band pixel value. Okay, so now how I can extract the band pixel value? For extracting the band pixel value, we have to use a function. This function called the sample regions. Okay, so in this time we have just apply the sample regions function. So for that, just take a variable. Suppose training. So basically these are training data set. Okay, so I put the variable training. In this variable, I stored all of those data set. All of those data set, mainly all of those training. Suppose 0 number training point, I extract all of those band value. Okay, from 0 to 122. So in this time, first of all, I need to declare about the image. Okay, so which image you want to use to extract the band pixel value? I want to use this variable image because this image is stored in here. Okay, just paste here image, and then I need the bands, all of those band. Okay, all of those band I need for extracting the pixel value. So for that, I use a function, select function, and select all of those band, and all of those band already stored in a variable. This variable name is the bands. Simply copy that and paste. Okay, and then we use the function, this function called the sample region. So mainly this function we are used to extract the band pixel value from a collection. Okay, so in this time it is a lot of feature collection, total 122. Okay, so I want to extract the band pixel value for all of those feature collection 122. Okay, so now just apply all of those argument one by one. I want to make a dictionary, so curly bracket start and also curly bracket end. So first of all, collection is that your sample collection. In this time my sample collection is that 122 and it is stored in a variable sample. Simply copy and paste here. Then properties. So properties, so mainly this property you can see when I want to declare the properties, I put here the class all time. Okay, properties will be same for all of those classes. You can see the class. The class. Okay, just I simply put here the properties and then set. In this time you can see properties. Okay, it is a plural form, not singular. So for that we have to use here the square bracket because it's a plural form, and then put here the property name class. Okay, so because it's the properties, so that's why you have to use here the must all time. When you can see any argument has a properties or plural form, must use here the square bracket, otherwise it not work. And then scale is that resolution of your satellite image. In this time Landsat 30 meter. Okay, so then it's not need, I simply remove that. So now I just simply print my data set and show you that how it will be look. So print the training and click the run. Okay, so here you can see here I can get the result For all of those training sample, extract the band pixel value SRB1 to SRB7. So here you can see total 8 properties is struck in here. You can see what is the value SRB1, SRB2, SRB3. We can get this value. Suppose another training sample, what is the value you can get? So in this time, all of those training sample extract the band pixel value for each point, each single point, extract the band pixel value. And this is my data set. Okay, my data set is stored in the training variable. So now this data set I need to separate or split into two ways: train set and test set. So it's a basic part of machine learning. When you want to do, you must divide the data into two ways: train set and test set all time. Just simply separate the data into train set and test set, and then further show you that. So in this time, how I can do that? In this time, I distribute the data randomly. Okay, so for that, I just take a variable. Suppose training data set. Okay, so in this time, all of those data I need to distribute randomly. So for that, I have to use a function, random column function. Simply copy and paste here, and then put the function random column. So in this time, this random column function randomly distribute this data and store it in this variable. Okay. So further, I just take the training sample and test sample data. Separate, spill the data. Suppose in this time I take the data, 80% data for train set, and suppose I also take the 20% data for test set. Okay, the data, 80% data for train set and 20% data for test set. So basically this is my it stored in here. So just I simply take a variable. Suppose I put the variable name is that train set, then call the training data set and paste here, and then use here the filter function and use here the art engine filter less than random 0.8, and also take the another for the test set. Take the variable, suppose test set. So just simply do the same things. So less than 80% randomly, and in this time I put here the greater than equal 0.8. So to the rest of the 20% data. Okay. So in this time I simply separate the train set and test set. So I simply separate the data. And now this train set I need to use for train my model, and this test set I need to use for check my accuracy. Okay. So for train your model, first of all, you need to create a model. Okay. So how we can create the model? So in this time we are using the model. So mainly model, when you want to create machine learning model, we have to use the classifier. Okay, so we can get the lot of classifier in Google Earth Engine platform. So here you can see the docs tab. Here you can see the classifier. Suppose I simply search here classifier. So here you can see we can get the lot of classifier. So basically this type of classifier we use here for the different types of work for the classification and regression analysis, as well as also prediction. Okay, so here you can see the one classifier is that cart classifier. You can see the classifier, and it's a built-in function. Okay, so already built in this function. So basically the cart or classification equation trees, this classifier has a lot of equation, a lot of things is available statistically, but in this time they are built in this function. So in this time this is the function about that cart classifier, but it has a lot of statistical background on the cart classifier or random classifier. or this is a minimum distance classifier. So this type of classifier has a lot of statistical background. So in this time I will not dip in the background because we have the another online training program for the future prediction, for also for that how we can easily use this type of classifier and also statistical background of this classifier. Okay, so in this time I show you that how we can easily use this type of classifier, not go in the depth. Okay, so in this time suppose I want to use here the suppose random forest classifier. Here you can see it is a random forest classifier, and this type of argument, number of trees we can get, variable per field, mean leaf population. Okay, so there are the lot of background of the statistical background. So in this time this is the number of trees, it is the compulsory, you must be used about that, otherwise it not create the decision tree. And what is the decision tree, what is the leaf node, and if you don't know about that, simply search on the Google. I think you can easily get the idea about that, what is the decision trees, what is the mean leaf node, about that you can easily get the idea. So in this time here you can see I want to use this model, suppose random forest model I want to use and train my 80% data. Okay, so for that I simply copy this model from here, and in this model we are get a lot of argument. Okay, and this time I simply paste in here, and in this time we have to input the number of trees. Okay, so what is the number of trees, how many number of trees I need to set in here for my model. So it is a big question about that. So suppose I put here the 150, suppose any somebody also uses 200, but what's the value I need to use, and after using this value I can get the better accuracy. I don't know what is the value about that. So random forest value, what is the exact value I need to put in here, I don't know. So for that we have to find out the hyper turning point. Okay, so hyper turning point means that suppose you want to find out a value, and which value is the perfect for your model. Suppose sometime you can see when I use at the 60 I can get the better accuracy, but when I use at the 100 then the accuracy is also low. So this value is not fixed. Okay, we have to find out this value. Okay, and this value called that hyper turning point. Suppose you use at the, suppose when I use at the 60 then I can get the best accuracy or better accuracy or highest accuracy I can get. So this 60 is my hyper turning point. Suppose I use at the 100 and I can get the better accuracy. So this 100 is the hyper turning point, is the 100. Okay, so when I use that the number of decision number trees is the 100, then I can get the better accuracy about that. So for that we have also need to learn about the hyper turning point, how we can easily, you can see I already added this my syllabus. Okay, so this thing is very important for that machine learning, hyper parameter turning, for improving the accuracy of your machine learning model. So these things you also need to cover. So how we can easily find out the hyper parameter turning for the specific model. Suppose in this model I don't know what the accurate number of decision trees. When I use it I can get the better accuracy. So for that we have to use the hyper parameter and then find out the value, and this value I simply put in here and then get the better accuracy. So in this time I don't know what is the value, so I randomly put the suppose 100. Okay, and then create the model first. After that we need to find out the value. So in this time this is my classifier. Okay, or this is my model. So this classifier I want to use to train my model. Basically 80% data set I want to train. So in this time I just use a function, train function, and put all of those argument one by one